Hello, so welcome back. In this video, we're going to talk about product and quotient rules. So if I ask you to find the derivative of y equals to 4 times x cubed minus 11 times x plus 3. Well, this function is not just simply sum of different polynomials, it's the product of two polynomials. So one way we can do it is we can just simply multiply it out to find the derivative, such as use FOIL to multiply these. I will have 4 times x fourth minus 11x. Let me take a step because some of you might forget FOIL. So 4 times x and then 4 times x cubed plus 3. I will have 12x cubed and then negative 11x. Negative 11 times 3, I have positive 13.3. All right. After that, we can just simply to take derivative by using the sum rules, right? Well, so when I take the derivative of this product, I will get 16x to the cube plus 13.6 x squared minus 11 plus 0. So to simplify, I have x to the 16 to the third, 13.6 x squared minus 11. Okay. But what if we want to find a derivative with more complicated function, such as fx equals to 4x to the fifth plus x cubed minus 1.x squared minus 11, x7 minus 2.7 to the x to the fifth power plus 120x plus 3. If you're trying to do that, are you trying to multiply each element like what we did earlier and then do the calculation? Well, that works, but that will give you a lot of work. Your workload is going to increase tremendous. So one way to do it is we can use our product and the quotient rules to do the derivative. So for the product rules, if you're trying to take the derivative of two polynomials multiplied together, such as f and g is two polynomials, I want them multiplied together, I will have f, we take the derivative of the first function times the second function plus the derivative of the first function times the derivative of the second function. So for quotient rules, you will have, if I have a derivative of f over g, two polynomial, this is equals to the first function derivative times the second function minus, this time is minus, the first function times the derivative of the second function over the second function squared. Okay, so now let's take a look at some examples. For example, I want you to find the derivative of this function. F of t equals to e to the t ln to the t. Okay, if you take a look at this function, we can consider, hey, this function is e to the t times ln to the t, right? So in this case, we can apply to our product rules. Our product rule is we take the derivative of the first function times the second function at the first function times the second function's derivative, right? So now I can write it as first function, second function, first function, and the second function. We can do it step by step. Take your time slowly since we just learned this. So for the first function, I'm going to use a triangle. The second one, I'm going to use a circle. So this is e to the t. And then I have ln to the t. The second function, first function, second function. Okay, after that, let's take the derivative. So the derivative of the first function, e to the t equals to what? Itself, right? E to the t times ln to the t plus this one, the first function, e to the t, we don't do anything about that. So the second function, we want to take the derivative of ln to the t. So the derivative of ln to the t from our earlier, part 1, the video, this is equal to 1 over t. Well, after you simplify it, you should have e to the t times ln to the t. Or you see there is a common factor, e to the t, so I can write it as ln to the t plus 1 over t. So that would be the derivative of this function by using the product rule to find out about that. So now let's try the quotient rule. Quotient rule means saying that, hey, if you have polynomial in a factor form, when you take derivative, you should follow these rules. All right. So now let's take a look. If I have a function y equals to x to the 4th plus 4x to the x power, and then 3 plus 16x. Okay, we're trying to use the product rules. The product rule says what? The first function, second function, the first function's derivative times the second function minus the first function and the second function's derivative over the second function's square. Now we filled in everything. The first function is x4 plus 4x, x to the 4th power plus 4x. The second function is 3 plus 16x, 3 plus 16x, 3 plus 16x. Now, when we try to take the derivative of this, I will have the first function. By now, you might be able to do it very quick. So this is what? 4x cubed plus 4, right? That's after you've done the derivative. Plus 16 to the x minus x cubed plus 4x times 3 plus 16x. 3 constant. When you take derivative of constant, you will get 0. And that means we just need to take derivative of 16x. So this is equal to 16. All right. And then square them. So after you did that, well, you can try to simplify it. That's fine. If you leave it that way, that's also fine, because all I care about is, in your homework, all I care about is whether you're understanding how to apply the quotient rules. That's it. If you want to continue to simplify, that's okay. In a quiz or test, if you do it as it is, that's also fine, because that shows that, hey, you understand the quotient rules. Okay, there is one more type, complicated function, that we will want to know how to differentiate. All right, then we will need to apply to our chain rules, such as if I want you to take the derivative of fx equals to 4x cubed plus 15x squared. If you take a look at this is not a simple polynomial, so we can't just use the basic rule that we just learned, such as quotient rules or the product rules, because this is not a product. This is you can consider this is two functions. What does that mean? You can consider one function, g of x is equals to 4x cubed plus 15x. So when we write fx, I can consider that is, hey, this is g of x, and then I want to take the square of g of x. I consider this part is one function, and then the fx is equals to the first function, which is the highlighted function, and then square them. Okay, so if you have some function in the form of that, then you need to apply for the chain rule. Again, I'm going to say that again. So if you see some function that they can write it into two functions, you should apply for the chain rule. So chain rule is follows if f and g, they're both a differential function, y equals to f of u and the u equals to g of x. So that means our y, I'm going to write here, y equals to f of g of x. So that means we can write the f function, we can represent the f function in the form of g of x function, like what we did in here. All right, in that case, the chain rule is, if I take the derivative, this is equal to dy du and then du dx. I will remember you how to do that. If you take a look, this seems like, hey, I can cancel du and dx. That is exactly what they want you to do. They want you to add another derivative in between the dy dx so that it will be easier for you to calculate them together. So in a word, how do I describe this chain rule? So I can say the derivative of this composition is the derivative of the outside within the inside staying the same times the derivative of what's inside. It sounds very complicated. I know, by now it sounds very complicated. I'm going to write it down. So the derivative of a composition function is the derivative of outside with inside staying the same, and then times the derivative of what's inside. Okay, so now let me go back to the example that we have in here. I'm going to show you how to apply the chain rules. So here I have a function y equals to 4x cubed plus 5 to the x squared. So now I want to let this is a function, right? So I want to let u, or g of x, any notation that you want it to be, equals to 4x cubed plus 5x. Okay, so that means your function can be written as what? Y equals to u squared, right? Okay, but remember, when you're taking the derivative, you're taking the derivative of x. Okay, so keep that in mind. So that means if I'm taking these, I will have 4x cubed plus 5x squared. So since these, I am replacing it with du, right? So that means by applying the chain rule, I have the function, which is 4x cubed plus 5x square, and take the derivative of that u, which is 4x plus 5x squared times d of u. Remember, that's the chain rule of ds. U is equals to what? Now u is equals to, let me rewrite this du as 4x cubed plus 5x. So that's the chain rule. So basically, this step you're doing is you're taking the derivative of du, dy at du times whatever inside of it and dx. Okay, So now when you take a look at the derivative of this first part, let's do the first part first. So the first part is equal to what? Well, if you consider this is u. Okay, this may look very complicated because remember 4x cubed plus 5x is equal to u. If I tell you that, hey, if I want to take the derivative of u squared, you know that, hey, this is going to equal to tu, right? So this is similar. You should look at this as a u instead of x 4 times x cubed plus 5x. So this is equal to 2 times u, right? All right, and then times whatever inside, which is our u, and then we derivative them at x. So that means we are trying to take the derivative of this part, which is 4 times x, 4 times 3 times x squared plus 5. When I simplify it, I have 2 times x, I have 8x cubed plus 10x times 12x squared plus 20. You can continue to simplify it, or you can just leave it here. Okay, this chain rule I know looks very complicated, so I'm going to show you another example on how to do the chain rules. For example, I want you to take the derivative of y 4x third plus 15x to the 20th. Okay, this one is not a simple product rule, and quotient rule can solve the problem for you. So that means you need to apply for chain rule. If I want to apply for chain rule, I need to think about, hey, what function that I want to consider is a whole function. Well, the easier way to do it is whatever inside of it, I consider this is equal to u, right? So I let u equals to 4x cubed plus 15x. Okay, when I try to get derivative y at x, I should have dy. Let's apply the chain rule. Y at u, I'm sorry. And then multiply du at dx. Okay, so now let's substitute everything inside of the function. So for y, I have 4x cubed plus 15x to the 20th power. I want to differentiate this at the u, which is 4x cubed plus 15x, right? And then times, again, we differentiate something inside, which is 4x cubed plus 15x. I will substitute the u inside. Okay, now, okay, this one, the first derivative, maybe looks complicated for you to differentiate that. But remember, this part, the highlighted part is u. This is u. So if you want to make it easier, you can do, hey, instead of derivative of 4x cubed plus 15x to the 20th power, you can rewrite this as u, right? So this is u to the 20th power and at u, right? So now this should be easier for you. Now for this one, I want to take the derivative of 4x cubed plus 15x. At x, I just take derivative of x, so this should equal to what? Well, I take derivative of that should be 4 times 3x squared plus 15, right? That's done. We've done the second part. So now it's the outside part. Well, u to the 20th power, you take derivative of that. So this is equal to 20 times u to the 19th power times whatever that is, 12x squared plus 15. All right, so now we need to rewrite the u. Remember, our u is equals to 4x cubed plus 15. So 4x cubed plus 15 to the 19th times 12x squared plus 15. So that's the chain rule. Well, by here it's fine. If you can go as far as to here, you don't need to continue to simplify it because 19th power is very hard to simplify it. So basically is for the chain rule, you trying to put something inside to make it easier for you to manipulate as a function. All right. Let me give you one more examples. For example, I want you to differentiate y equals to e to the x squared plus 5. So this one, you can't just use a product rule or quotient rule, right? You need to use the chain rule because you can see this is two functions. You can let u equals to x squared plus 5. Okay, when you try to take the derivative of y at x, I can do it as you taking derivative of y at u times hold on. Times the derivative of x. Derivative u at x. Okay, again, to do that, let me rewrite the function. Well, y is equals to what? Y is equals to e to the e to the x squared plus 5, right? And then u is x squared plus 5 times du, which is x squared plus 5 at dx. Okay, again, this one, if it's hard for you, remember you can write this as u. So in that case, it will be easier for you to differentiate that. I write it as e to the u over du. And then times the second part, which is the inside part, your dx. This one is equals to 2x plus 0, so which is just 2x. Okay, e to the u, you differentiate at u, so this is equals to e to the u times 2x. Again, we rewrite u back, which is x squared plus 5. So have e to the x squared plus 5 times 2x. So that's the differentiated. Let's try a very complicated function that apply every knowledge that we learn, such as fx equals to e to the 3x times ln 5x plus 7. Okay, first you see the multiplication. So the first thing is I want to apply the product rules. So remember the product rule is the first function, second function, the derivative of the first function plus the first function times derivative of second function. Now we write here, the first one is, I'm going to use the triangle to show the first one, e to the 3x. And then the second one should be ln 5x plus 7, ln 5x plus 7. Okay, e to the 3x, I want to take the derivative of here. Well, we need to apply for chain rule because there is another function inside of this polynomial, which is 3x. So to apply to chain rule, how do we do that? Well, let me write it on the side, and then we can substitute back. So I want to take the derivative e to the 3x. So apply chain rule. This is equals to, I want to let u equals to 3x. So that means when I take derivative of 3x, which is our u, at es to the 3x, times derivative of the u, which is 3x at x. Okay, if I consider this as 3x, I try to take the derivative of 3x. So again, I look at this as u. Well, let me write this in the red. So this is u, this is u. So that means I take the derivative eu at u. So that means this is equal to itself, e to the u, right? And then times the derivative of 3x, that gives you 3. So this is equal to 3 times e to the u. 3 times e to the u. Again, I need to write the u back equals to 3x. So this is equal to 3 times e to the 3x. Okay, we take off the derivative of that one. We write this back. 3 times e to the 3x. All right, so the second function, we write this down. Okay, so for this one, I'm afraid that we also need to apply for our chain rule. I am going to write it here as our scratch. So I want to find the derivative of this guy. What do you do? Well, I want to let this function to become u. Okay, so that means I want to take derivative of this guy at du, which is 5x plus 7 times the u, 5x plus 7 at dx. Okay, so again, if you consider this whole thing is a u, right, ln to the u power, and then we derivative at u, so this is equals to 1 over u by the rule times that part, 5x plus 7, this is equal to 5. Okay, 1 over rule. Again, I want to write this into the u equals to 5x plus 7. So this is 5 over 5x plus 7. So that's the derivative of ln to the 5x plus 7. So I will write it back. So that's it for the whole derivative of this complicated function. So we are applying two things. One is the product rule. To separate them, after the product rule, we try to take derivative of the first polynomial. We use a product rule. We also, when we're trying to take the derivative of the second function, we also need to apply for a product rule. Okay, last things. So a function is called differentiable at the point if the derivative exists at that point. But what about the slope doesn't exist? What does that mean? So on the graph, what does that look like? When does the slope doesn't exist? Well, only in one case, right? If this is a vertical line, then the slope won't be exist. So that means if the tangent line of the point is a vertical line, the slope doesn't exist. So that means the derivative at that point don't exist. Such as if I have a graph like this one, at a certain point, let's say this point won't be, let me draw another line. If I have here, this is x equals to 4, so that means the tangent line is a vertical line at 4. So that means when x equals to 4, the derivative doesn't exist. If it doesn't exist, we can say, hey, the function f(x) is not differentiable at x equals to 4. Okay, so that's it for today. I know the chain rule is really complicated, but the more that you practice, the more that you will understand it. Please try to do the homework and check your answer with my answer. I have a very detailed solution on that.